Hello everyone, my name is Sang. I'm lecturer at Vinh University, Vietnam. I'm pleased to present our research on advanced heuristic solution for the hospital resident matching quick type problem. This problem involves matching resident to hospital while addressing type or equal preferences. Our study introduced an advanced heuristic approach that optimizes this matching process, aiming to improve outcome for both hospitals and residents. I look forward to share our finding and discussing their potential application. My presentation consists of 5 main sections: introduction, related work, proposed algorithm, experiments, results, and conclusion. As you can see in this slide, the hospital resident problem is many to one matching of the stable merit problem, which is introduced by Gay and Shackley in 1962. This table presents an example of HR problem. It consists of resident preferences, hospital preferences, and the capacity of hospital. And the goal of HR problem is to find a stable matching. HR is unrealistic for real-life application because it requires each member to rank either in strict preference order. The most popular extension of HR problem is hospital resident problem with ties, we call HRT. HRT problem will apply in National Resident Matching Program in US, in Scottish pre-registration how official allocation in UK, and Canadian Resident Matching Service in Canada. This slide presents the definition of matching, the blocking pair, and the stable matching. As you can see here, the matching aim is set up resident and hospital which had to satisfy 3 criteria here. And we have the definition of blocking pair here. And the matching is a set table if there is no any blocking pair. Otherwise, it's called as unstable matching. For the related work, in recent years, almost all the algorithms that has been proposed to solve mark HRT are approximate approach. Since mark HRT is NP-hash problem. And you can see here the Manlove et al. You HRT approach for stable matching in HRT problem. And some other researchers also propose like adaptive search AS for solving the mark HRT problem. I'd like to talk about our proposed algorithm to solve mark HRT problem we call HSHRT. The main idea is we try to reducing the average execution time for mark HRT a plus size and maximize the number of residents assigned to hospital. To reduce the execution time, the idea is that we only consider the resident we can generate a blocking pair and find an undominated blocking pair from resident point of view instead of all residents at each iteration. And we try to maximize the number of residents assigned to hospital. To do this, we propose a strategy to improve the stable matching size by promoting under a subscriber hospital in the same time and unsigned resident without restarting from a random matching. As you can see here, it's a pseudo course of HRT algorithm. And in this algorithm, we use a function named improve matching. Here is the pseudo course for improve matching problem that were proposed based on 2 main ideas: is to reduce the average time execution time and maximizing the number of residents assigned to hospital. For the experiments, we conduct 2 experiments to compare our proposed algorithm with other algorithm we call HRT. Here, the first experiment is we randomly generated 100 HRT instances for a combination of parameter. N is 200, M is 20, and P is from 1.2 to 1.8, and P2 is from 0 to 1. So we have the total of instances were 8,800. It means that each resident rank about from 4 to 18 hospital, and each hospital rank about 14 to 180 residents. Whereas the P1 decreased from 0 to 8 to 0 to 1, respectively. For each generated instance, we said capacity of hospital is equal to 10. As you can see in the figure, our proposed algorithm, which presented by the dot line black, and the ASHRT problem with our algorithm presented by the red line. And for the percentage of perfect matching, we have a better results. And as you can see here, we have the lower number of unsigned residents. You can see in the black dot line. To compare the execution time, we have lower execution time, our execution time here. And for the number of iteration, we also have lower number of iteration time. And for the second experiment, we randomly generated 100 HRT instances for a combination of value is same as experiment 1, but we have different in the capacity of hospital. We also generate randomly the integer number between 0, 1 Q to 0, 4 Q, where Q is total number of residents ranked by hospital H for all H in the hospital lead. It can be understood that a hospital rank Q resident but choose from 10% to 40% resident in its rank list. Here the results of comparison. As you can see here, our proposed algorithm to have better result in compare with the percentage of perfect matching. And also we have still have lower number of unsigned residents. And for the execution time, we have lower execution time. So for both experiments scenario, still at a faster execution time and bigger in the percentage of perfect matching. For your conclusions, we already propose an heuristic algorithm named HSHRT to solve the mark HRT problem. The main idea is we start from generating and random matching and iteration, refine it to find a maximum stable matching. In each iteration, it identifies and removes undominated blocking pair. If algorithm encounter a non-perfect matching, it repairs the acceptable pair within matching and continue the process until find the perfect matching or reach the maximum number of iteration. If the last occurs, the algorithm return at last is stable matching. For your future work, we would like to extend it approach to solve other variant of FPA problems such as FPAS or FPAT. So thank for listening.